everybody. Today I'm going to explain about map interface. Map is an interface. Okay, Java map interface contains values based on key value pairs. That is, map contains key and value pair, and each key and value pair is known as an entry. A map contains only unique keys, and a map is useful for operations like search, update, delete elements on the basis of a key. And map does not allow duplicate keys, but it can allow duplicate values. And hash map and linked hash map and tree map are the implementation classes for the map interface. And hash map and linked hash map allow null keys and null values both. But tree map does not allow any null key or value. First, we'll see what is a Java hash map. Java HashMap class implements the map interface, which allows us to store the key and value pair where keys should be unique. And it is used to perform operations using the key index like updation, deletion, etc. And this HashMap class is found in java.util package. If you consider the difference between HashMap and hash table, hash table is a legacy class. Legacy means it is a old type of class, and whereas hash map is not synchronized and hash table is synchronized. Hash map is not synchronized, whereas hash table is synchronized. Non-synchronized means not thread safe, that is multiple threads access simultaneously. Synchronized means thread safe, that is only one thread can access at a time. So hash map allows us to store the null elements as well as null values, but there should be only one null key. And HashMap inherits the abstract map class and implements the map interface. Now we'll see what is this Java linked HashMap class. Java linked HashMap class is a hash table and linked list implementation of the map interface and with predictable iteration order. So Java linked HashMap inherits the HashMap class and it implements the map interface. What is this Java tree map class? Java tree map class provides an efficient means of storing the key value pairs in the sorted order. Tree map is nothing but the elements are stored in the sorted order, that is ascending or the increasing order. Java hash table class. Java hash table class implements a hash table which maps keys to values. It inherits the dictionary class and implements the map interface. Next, we'll see what is a comparable interface. Java comparable interface is used to order the objects of the user-defined class, and this comparable interface is found in java.lang package, and this comparable interface contains only one method, that is compare to method. Comparable interface contains only one method, that is compare to method. That is, it provides the single sorting sequence only, that is, you can sort the elements on the basis of single data member only. Next is comparator interface. Comparator interface is used to order the objects of a user-defined class, and this comparator interface is found in java.util package, and this comparator interface also contains two methods, that is compare method and equals method, whereas comparable interface contains only compare to method. Comparative interface provides multiple sorting sequences, that is, you can sort the elements on the basis of any data member, for example, roll number, name, age, or anything else. So what is the difference between comparable and comparator? Comparable interface has only one method, that is compare to method, whereas comparator interface has two methods, compare method and equals method. And comparable interface provides a single sorting, that is, you can sort the elements on a single data member, on the basis of single data member, whereas comparator interface provides multiple sorting sequences. That is, we can sort the elements on the basis of any data number. Vector. Now, what is a vector? Java vector is like a dynamic array and which can grow or shrink its size. So is uh, vector is similar to a array list. Vector is similar to array list, but which is also growable array. Vector is also a growable array. That is, the elements can be added, inserted, or removed at any position. Both array list and vector contains predefined methods to perform various operations on elements. But comparing to array list, vector is more efficient. And vector is serializable, that is, all types of objects can be stored in the vector, whereas array list is not serializable. So vector is more efficient compared to array list, and vector is a dynamic array, that is, the array can be growable, and it is a vector is also part of Java collection framework, which is found in java.util package, and vector implements the list interface. And so vector is a thread safe implementation. Thread safe means vector is synchronized. So vector is a legacy class. So that is why vector is synchronized. So we'll see some examples here. So what is a hash table here? Public import java.util.star package, then public class hash table example. Always the control starts from the main method. Since hash table is a class, we can create an object for the hash table. Hash table hm equal to new hash table. Then hash table, how to insert elements into the hash table using the put method. hm.put 100 comma Amit, hm.put 102 comma Ravi, hm.put 101 comma Vijay, hm.put 103 comma Rahul. Then for map.entry m hm.entry set. That is, we are using a for each loop here. So then system.out.println m.get key plus m.get value. So we'll see the output of this program. So hash table is also like hash map. Where the value data is stored in the key value pairs. Here 100 is the key and Amit is the value. So it does not preserve the insertion order. Hash table does not preserve insertion order. So insertion order means in whatever order you give the input, you will get in output in the different order. So hash table does not preserve the insertion order. So this is about hash table. Next is the map. We'll see about map interface. So this is the example for map import java.util.star public class map example. Always the control starts from the main method. Since map is an interface, we cannot create an object for interface, map interface. So just we create an instance map equal to, we can create an object for new hash map. Then this map is having the method called put to add the elements in the key value pairs. How do you add the elements inside the map using key value pairs? So map dot put 100 comma Amit, map dot put 101 comma Vijay, map dot put 102 comma Rahul. Then the elements can traverse in any order. For the map interface, elements can traverse in any order. So this is using for each loop. For map dot entry m map dot entry set begin, then system dot out dot println m dot get key plus m dot get value. And we'll see the output of this. See here, 100 is the key value, Amit 100 is the key and Amit is the value here, 101 Vijay, to Rahul. This is about the map interface. And next one is the hash map. We'll see hash map example. Public import java.util.star public class hash map example. Always control starts from the main method. Since hash map is a class, we can create an object for the hash map. Hash map equal to new hash map. And how to add elements using key value pairs. Map.put 1 comma mango, map.put 2 comma apple, map.put 3 comma banana, map.put 4 comma grapes. Then system.out.println iterating hash map. Then for map.entry m, how do you iterate the hash map? We can iterate hash map using for each loop also. So this is the syntax for each loop. For map.entry m colon map.entry set begin the system.out.println m.get key plus m.get value. So we'll see the output of this program. So how do you get the values? Iterating hash map. 1 is mango, 2 is apple, 3 is banana, 4 is grapes. That is hash map also gives the output in the form of key value pairs. Next is the linked hash map. What is linked hash map? Public class linked hash map. Control starts from the main method. Since linked hash map is a class, we can create an object for linked hash map. Linked hash map hm equal to new linked hash map. Then hm dot put 100 comma Amit, hm dot put 101 comma Vijay, hm dot put 102 comma Rahul. Then how do you traverse the linked hash map using the for each loop? For map.entry m colon hm dot entry set. That is linked hash map is having one method called entry set. Then system.out.println m.get key plus m.get value. Then we'll run this program. So see here, the output is in the form of key value pairs. Next we'll see vector. Now what is vector? Public class vector example. Always control starts from the main method. Since vector is a class, we can create an object for vector. Vector v equal to new vector. Then how do you add the elements into the vector? Using add method. V dot add Ayush, V dot add Amit, V dot add Ashish, V dot add Karina. Then how do you traverse the vector? Using the iterator interface. Since iterator is an interface, we cannot create an object because we can create an instance. Iterator itr equal to v dot iterator. There is a method called iterator method in the vector class. Then when it is checking whether the iterator is having any, the vector is having any next element. If it using the iterator dot has next. If it is having the next element, it will bring the next element. We'll see the output here. See, this is the output. So this is about vector. Next is comparable example. I'll show you this comparable example. Public class comparable implements comparable interface. Okay, comparable is an interface. I'm taking int roll number, string name, int age. Now, first of all, what is a comparable interface? Comparable interface is interface which is having only one method, that is compare to. And this performs comparable interface performs sorting based on only one value, that is using either roll number or name or age. This comparable interface can perform sorting using either roll number, name or age. Only one sorting can be done only based on only one value only. That is comparable EX is a constructor here. Int roll number, string name, int age. Again, this dot roll number is equal to roll number. This dot name is name. This dot age is age. Public int compare to. Age is equal to st dot age, return 0. Else if age is greater than st dot age, return 1. Else return -1. Now I'm taking one more class. So this is the program for comparable, and so I'll conclude here, and we'll continue in the next class.